algebra students. Today we're going to be reviewing what you know about function notation. So we have this situation that says the cost of buying some candy bars, we're going to use C for our function, B for candy bars. And we want to be able to explain what each of these different expressions or equations means. So what I just have C of 10, this is really just saying the cost of 10 candy bars. Now, this wasn't an equation. It doesn't tell me how much they cost. It doesn't give anything with an equal sign. That's all I can write here. It's just the cost of 10 candy bars was the entire expression. Now, this one is an actual equation. So I know that my input is 3. So I'm talking about 3 candy bars. So this is going to be the cost of 3 candy bars. And this time I know how much that cost is. The value of that whole function this time is given to me, and that cost is $8. So I know how much 3 candy bars would cost. And this one is just comparing 2 different values. The cost of 5 candy bars versus the cost of 7 candy bars. And it does make sense that 5 candy bars should cost less than 7 candy bars. Right? So we should be able to take things that are in function notation and be able to interpret them to say what that function notation really means. Then we should be able to take things that are written in words and be able to write them into function notation. So to get the output, add 5 to the input, and then divide by 3. So again, we're writing these in function notation. So function notation would look something like this. You don't have to use F for your function. You can use a different letter if you'd like. But to get the output, add 5 to the input. So the way that I've written this, X is my input. I want to add 5 to my input. And then I want to divide that whole answer by 3. So the entire thing needs to divide by 3. You don't need to use parentheses around the x plus 5 as long as I've got that entire thing in a fraction. You could use parentheses if you wanted to. For the second one, it says to get the output, multiply the input by 7 and then subtract 4. So for this one, function notation, multiply the input by 7. So 7 times the input and then subtract 4. These are just translations. That shouldn't be too difficult. For the third one, I kept the same numbers, but I changed around the order a little bit. To get the output, subtract 4 from the input, and then multiply the result by 7. So I have to be careful on this one. I'm still going to use f of x for function notation. Subtract 4 from the input. So the input is x, and I'm going to subtract 4. But I need to multiply the entire answer there by 7. This is going to have to look like a distribution. So this answer, to show that I had to do my subtraction first, has to be in parentheses. You could put the 7 after the parentheses if you wanted to, or in front, either way. But it has to be in parentheses to show that I had to do my subtraction first. Now, I've got 3 different functions up here. And again, the different letters for the functions tell me which function I'm using. So I've got an f function, a g function, and an h function. And I want to be able to evaluate each of those with the different input values that I have here. So my f function is f of 8. So I would want to put in -2 times 8 and then add 1. So -2 times 8 is -16 plus 1 would give me -15 for my answer. G of -6, this is going to be 1/2 times -6 minus 2. So half of -6 would be -3, and then -2 or plus a -2 would give me -5 for my answer. And h of 3, I would have 7 minus 3 is going to be 4. Then I've got a couple more here. G of 12, I would have 1/2 times 12 minus 2. So 6 minus 2 would be 4 for that answer. H of -7, so I would have 7 minus -7. So be careful there because that's not going to be 0. We could do a keep change here. That's actually going to be 14 for our answer. Circling answers before. All right. And for our last one, f of -5. So I would have -2 times -5 plus 1. So I would have 10 plus 1 would give me 11. So that's just evaluating using the functions that were given to us. If I keep those exact same functions, and now I know the value of those functions, but I want to know what the x had to be as the input. So if I know that f of x is equal to 19, I would use that f function. So I would know that -2x plus 1, that's what that f function was equal to. I want that to be equal to 19. Now I just have to solve this equation. So we get rid of our 1 and then divide by -2. So x would, oh, that's a -2. X is going to be -9. And for our g function here, I've got 1/2 x minus 2 equals -8. So I could add 2. So I have 1/2 of some number equals -6. And again, hopefully you'd be able to just do that in your head, but we should show our work here. I'm going to multiply by the reciprocal, which is 2/1, or just 2. And I hope that this number makes sense. And that answer should be -12 because half of -12 should be -6. Oh, and I just made that pretty much impossible to read. Let me fix that. There we go. All right. For our h function, h of x is 7 minus x. So 7 minus x equals 20. Some people make some mistakes when the x isn't first. So be careful when you're solving this. Keep in mind, you're saying 7 minus something gives us a bigger number. So keep in mind what that should mean. X has to be a negative number. We have to be doing 7 minus a negative number to turn it into an addition. So I'm going to subtract 7. And I'll really have negative x, or negative 1x, equals 13, and then I'll divide by negative 1. So x is going to be negative 13. And if you check that, that does make sense, because 7 minus a negative 13 does give me a positive 20. And for our last one, f of x equals negative 15, I would have negative 2x. Negative 2x plus 1 equals negative 15. So if I subtract 1, that gives me negative 2x equals negative 16, and then divide. So x will be 8. Right? And you can certainly go back and check any of those just by doing a substitution. The last couple problems are just understanding how to read graphs and understanding what the input versus the output means when we're looking at these kind of graphs. So on this, when I'm asking for the value of d of 1, the 1 is really the input value. That's right here. So d of 1 is asking you to follow this up here to the graph and then figure out what the output is. Wow, I didn't draw that very well, but that should be right here at about 3.5. So that's saying after 1 hour of biking, I'm answering the context part of this now. So after they've been biking for an hour, they are about 3.5 miles from Angie's house, right? 1 hour of biking equals 3.5 miles from Angie's house. So make sure that you understand that the number that's in the parentheses is the input. That's on the x-axis, that's the independent variable. And then when we're looking for the output, the value, that's on the y-axis. So take a look at this one. Which values of t make this statement true? I want d of t equal to 2. That's the value, that's the y part. I want to know when the y is equal to 2. So that's saying right here. I want to know when that happens and when that happens. I want to know when the time is. I want to know what the input is, or what the x value, what the t would be on this. So this is probably about 0.75. So that's at about 45 minutes. And then it looks like this other one is probably at 2.5 hours. So at about 0.75 hours and 2.5 hours. Both of those times are when they are 2 miles from Angie's house. So in this graph, they're going away from Angie's house and then they are coming back to Angie's house. So today's homework is the function notation worksheet. If you have any questions about that, please make sure that you reach out to your math teacher.